So we've been talking about chemical and physical properties, and you should know by now that a chemical change is one that involves a chemical reaction. So today we're going to talk about chemical equations, which is how we represent chemical reactions, and how to balance them. So the first thing is, how can we tell if a chemical reaction has happened? So a chemical reaction is when some new chemical is formed. It involves rearrangement of the bonds of the atoms, right? So there are 4 different indications of a chemical reaction, and I'll do some demonstrations of these for you in class as well. But you've probably witnessed these in your everyday life. So the first one is formation of bubbles or formation of a gas. And you shouldn't confuse this with something boiling. That's just a change in state. But formation of a gas in terms of chemical reaction happens with baking soda and vinegar, for example. You get bubbles and you know that a gas is being formed. Right. The second one is a change in color, and everyone has probably witnessed this as you leave something metal outside and it turns from the dark metal color to a rust color. So that is an indication that a new solid has formed and the color is different. And you may have also witnessed this if you look at something that's copper exposed to the elements turns green. So this is why the Statue of Liberty, who is made out of copper, actually appears green. All right, the third one is formation of a solid or a precipitate. And so we'll do some examples of this in class, but basically what happened here is you have 2 solutions that are clear with nothing in them, and when you mix them together, it gets cloudy, and that cloudiness is the precipitate or solid that is forming. All right, and then the last one is production of heat, or sometimes light or flame, or the absorption of heat. So if you mix 2 things together and they get substantially hotter or colder, then that indicates a chemical reaction. So fireworks and just burning a fire are 2 examples that you might be familiar with from your everyday life. Now, a chemical equation is what we use to tell us what is happening during a chemical reaction. So a chemical equation is very similar to a recipe, and I'm going to just use a very simple recipe here. So if we wanted to make cheese sandwich, we would need to do cheese plus bread, and that would equal our sandwich. All right, so in order to do this, we write this as a chemical equation where the things we start with, which are called reactants, go on the left-hand side. And then we use an arrow, which is essentially equivalent to an equal sign, but the arrow means that this is what it becomes. And then sandwich would be our products. So products are the things that you end with in your chemical equation, and they always are on the right side. Now, just like in a recipe, you need to know how much of each thing is going into your recipe. We need to specify how much of each of our reactants we have in our equation and how many products are formed. So our unbalanced equation would be bread plus cheese yields a sandwich. But if we want to balance that and tell how much of each thing we have, we would use 2 bread, and we're just using the symbol BD for bread, plus 1 cheese, and we never write the 1 because it's just assumed, yields our sandwich, which is 2 breads and a slice of cheese. Okay. Now we can do the same thing with chemicals and element symbols that we've used so far in class. So for example, if we wanted to explain how water is made, we know that it's made from hydrogen gas and oxygen gas, all right? But we don't have the same number of hydrogen and oxygen on one side as we do on the other when we make water, and so we need to balance our equation. And so in order to balance this, we would need 2 hydrogen gases plus 1 oxygen gas, and those together would give us 2 molecules of water. And these big numbers on front that tell us how many of each element or molecule we have are called coefficients. Here are the steps for balancing equations, and we're going to go through 2 examples just to practice these steps. And like I said, we'll practice a lot when we get to this in class. So the first thing you need to do is write an equation using the correct formulas for reactants and products, including the conditions. So this is the first time we've done this, so S stands for solid, L for liquid, G for gas, and AQ for aqueous, and those are always written in parentheses after the element or compound and with lowercase letters. Okay, so you should now know what those stand for, and we'll practice writing them when we write out chemical equations. So this first example, that's already done for us, so we can skip that step. All right, the second step is to count the atoms of each element in the reactants and the products. So in this reaction, we have carbon, we have hydrogen, and we have oxygen. And then in the reactant side, right now we have 1 carbon, 4 hydrogens, and 2 oxygens. On the products, we have 1 carbon, 2 hydrogens, and 3 oxygens. Okay, so we have oxygens in 2 different places here on the product side, and we need to count both of those. All right, the next step is to use coefficients to balance each element. And I generally tend to use as a rule for myself to leave elements that are in more than one place to the end. So that would be oxygen in this case because it's in more than one compound in the products. All right, so let's start with carbon because that's the one we wrote first. So we have 1 carbon on each side, so that one is balanced. Great. All right, we have 4 hydrogens in the reactants, and we only have 2 in the products. So how are we going to change that? We're going to put a 2 here in front of the water to make 2 waters. All right, that's going to change the number of oxygens over here as well as the number of hydrogens. So that's going to give us 4 hydrogens in the product, and we already had 4 in the reactants. And then when we add up the 2 oxygens in the water and the 2 oxygens in the carbon dioxide, we end up with 4 oxygens total. All right, but we only have 2 oxygens in the reactants, so we need to account for that. So we can make 2 O2s to get 4 oxygens total. All right, so now we just want to go back and double check. We have 1 carbon on each side, we have 4 hydrogens on each side, and we have 4 oxygens on each side. So that one is balanced, and we can rewrite our equation here in its final form, balanced. Now this example is given in words, so we do have to do the first step. So the first step is to write out our equation. So lithium metal, so we want to write Li for lithium, and given that it's a metal, it's going to be a solid, so we'll put our S in parentheses, plus liquid water. So this tells us, we know water is H2O, and it tells us it's in liquid form, so we do a little L. Reacts to form hydrogen gas. So hydrogen gas is H2, and we want a little G there to tell us it's a gas, and aqueous lithium hydroxide. And you should hopefully remember from your naming that since lithium has a +1 charge and hydroxide is polyatomic ion with a -1 charge, we just need one of each of those. So the formula for lithium hydroxide would be LiOH, and it's aqueous, so we're going to put a little AQ after it. Okay, so now we want to count up how many of each element we have. So we have lithium on both sides. We have 1 in each case. We have hydrogen on both sides. We have 2 hydrogens in the reactants in our water. And we have 3 hydrogens in our products. 1 in the lithium hydroxide and 2 in the hydrogen gas. And then oxygen, we have 1 in our reactants, and we have 1 in our products. So right now everything is balanced except the hydrogens, okay? So if we have 3 hydrogens over on one side and only 2 on the other, so we need more hydrogen on the reactant side. So we're going to have to make the coefficient of water a 2. That's a good place to start. And now we'll have to update all our quantities. So now we have 4 hydrogens and 2 oxygens, okay? But now we're still not balanced because we have 4 on one side and 3 on the other, all right? So in order to make that work, we're going to have to put 2 lithium hydroxides. That would give us 1 additional hydrogen. But now we've changed our lithium to 2. We now have 4 hydrogens, and we now have 2 oxygens. All right, so if we look at what we've got, we are balanced in terms of oxygen. We have 2 of each. We have 4 hydrogens on each side, so that's great. We have 2 lithiums in the product and only 1 in the reactant. So we're going to have to put a 2 here to give us 2 lithiums. All right, so now we can double check that we have the same number of everything on each side and rewrite our equation to be 2 lithium plus 2 H2O gives H2 plus 2 LiOH. All right, and now we're balanced.